Welcome everyone today to Functions Leadership Exchange, Outside In, a look at high performance building facades. My name is Megan Tinkler and I am an account specialist here at Function. And so we do these exchanges periodically with different leaderships and different roles and different experts to gain knowledge to present to some of the clients we work with. And through our experience working with a lot of our clients, one of the main aspects of coming up with high-performing facades is the building envelope. You know, walls, windows, doors, and how they act together to create the finished building. And all of the manufacturers that we work with, they represent products in all these categories. And constantly, you know, where there's a lot of discussion about how to create a tight and energy efficient envelope and how it can be challenging and how that relates to their customer base and marketing their product. So today we're we're sitting down with some experts in the industry, and we're going to talk about these challenges and how different things affect it and how we can navigate to use this collaboration design to build more efficient buildings from the outside in. So I'd like to introduce you to the panelists we have today. We have Blake Talbot. Blake is an associate principal, quality assurance lead, and firm building enclosure expert for BBH Designs, and they have over 50 years of construction and specifying knowledge. BBH Designs has 10 years, has become the third largest architectural firm in North Carolina, and was recently recognized by Healthcare Magazine as the 10th in the nation for healthcare work in 2012. So thank you, Blake. Next, we have Tom Butler. Tom's work includes research for the U.S. Department of Energy Building America program and energy modeling, building envelope testing, and performance monitoring services for a wide variety of South-based Energy Institute partners. Tom has been presenting on building performance at conferences hosted by AIA, American Solar Energy Society, U.S. Green Build Council Triangle Chapter, and the Association for Preservation Technology International. So thanks, Tom. Paul's unable to be with us today, but we will skip over him and move on to Bob Dazel. He has over a decade of experience as a project architect for numerous large-scale governmental and institutional projects, and was a faculty member at the University of Toledo in their Engineering Architecture Association degree program. He spent the last 16 years in the exterior insulated wall cladding industry and has become an authority and an expert on exterior wall surfacing materials, building envelope design, detailing specification, and performance. And for the past 12 years, he's been employed by Dryvet. So thanks all you guys for joining us, taking some time out of your day to kind of give us your knowledge on building envelopes. I think you each are going to bring a unique perspective with being an analyst and an architect and working for one of the manufacturers of Dryvet and so forth. So thanks for joining us. And I'm going to start off. I'm showing you the first question here. What I'm going to do is I will we'll go through these questions, and I will hand them off to a few of you at first, specifying who can maybe answer it. But it's open for anybody to answer the question. I just do that for organizational purpose so we can get the ball rolling. But so anyone, please feel free to speak up if it's a topic that you really feel you have a lot of information to provide. I welcome your thoughts on that. And there'll be a few questions like this first one I'm going to open up to the entire board. So our panel rather. So let's go ahead and get kicked off as we look at the high-performing building facades. So first and foremost, what is the latest industry trends impacting the design of more efficient building envelopes? I'll go ahead and open this up before we get to the second part to the board, if Blake or Tom or Bob would like to answer.
Yeah, I'd be happy. This is Bob. I'd be happy to open the conversation and thank you for having all of us aboard. I think kind of unique for us today from my perspective as it relates to industry trends is that we're a little bit more of the codes or the new energy codes that are coming into play, and some of which are yet to be adopted, perhaps even being a little bit out in front of what some of the technologies or industry trends are. So I perceive or see that some of the industry trends right now are those that are attempting to figure out how to cost effectively, meet these new energy code requirements that are associated with the building envelope design.
Right, right. What about you, Tom? What are your thoughts?
Well, what we're seeing is, at least on the code side, and from the Army Corps of Engineers, envelope testing is becoming a big, a new piece of code compliance, and the state of Washington has a standard that is similar to that of the Army Corps of Engineers. So we're actually going in and having to measure the tightness of the building envelope in order for the building to even get its certificate of occupancy. So that, and on the residential side, that's already a requirement in the 2009 IECC, and with the 2012 version, the level of tightness has gotten even more stringent.
Right.
Now, Blake.
Go ahead.
I agree with Tom. I agree with Tom in the fact about the testing and so forth, and trying to increase the quality of the building enclosure has become tantamount. We've got the products. We've got, in many ways, and some of them will be continue to improve, and we'll talk about that later. But I see really, too, there's some other challenges that I've seen as far as craftsmanship needed, union or non-union. This is really impacting the building enclosure, the efficiency of it, and trying to test it. I think we're doing earlier testing, and that's going to help some. We're going to get, and we'll get into commissioning probably later in the next part of this first question. But the challenge is smarter enclosures are needed. We have smartphones, cars, dishwashers, washing machines, and so forth. But we are just in the infancy of what I say is smarter building enclosures, and something that needs to develop and is developing, but a little bit slower. And a lot of it has to do with the availability of craftsmanship and some other components that we can talk later about.
Sure. So, you all brought up some good points, and I know that. So, Lead 4 has not come out yet. I know that it's upcoming, and we're still dealing with the third generation here. But do either of y'all expect, it's going to affect it probably somehow? Do you think there'll be some more stringent guidelines? What would be your take on what you expect to see as we get the Lead 4 requirements soon?
Well, this is interesting. This is Blake again. I thought this was interesting. I attended a meeting last night, and it was somebody that kind of has kept up our meeting at CSI on the whole area of lead, and has done a great job in what the V4, the version 4 updates are. From my perspective, from what I saw, they're adopting some more things as prerequisites now that were something that you had to earn or could work with, but now they're prerequisites. One of the biggest ones is going to be, and sort of what Tom was talking about, the testing is going to be the building enclosure commissioning as a part of the overall. So the potential, if it's done and implemented correctly with people that understand particular building types, I think it's going to be a great resource and everything else. It's something that's been working through the industry anyway. And the ICC and so forth are slowly getting this and implementing it, but now local code areas within the state or whatever have adopted this yet. In fact, they haven't even adopted the 2009, or just adopted the 2009 for our state just this last year.
Bob, what about you? I know that you've got some LEED certification. What are your thoughts about what V4 will bring for us?
Yeah, I think that the point about building commissioning is very important. Not to ignore, that LEED all the way up to our current version 3 has really specifically targeted or forced the designer to look at the whole building energy simulation, or the efficiency of the building envelope and the building on a whole. I mean, that's the category under energy and atmosphere credit 1 where the most LEED points can be potentially earned. Version 4, with the added ingredient of commissioning specific to the building envelope, is going to force us to take a look at our buildings and know that they work or perform instead of hope that they work or perform. And that's going to be a pretty dramatic change.
Mm.
Right.
Yes.
Right.
Yeah, and I would kind of echo what Bob is saying about the total energy performance and looking at a broad picture of what facade design is, and where LEED V4 is really going to push things is the all-glass building is going to be a real penalty for people because of the envelope values that you're going to have to achieve to in your baseline models for LEED certification.
Right. Right. Okay. Well, let's kind of delve a little bit further into there we go. The definition of what high performance means. I mean, as we sit here and we talk about the different, certifications they're going to need, but I guess we can even back up further to say, what is the high performance? It's a vague term. So how would you define it and how it applies specifically? Because I think there's a lot of different terminology out there that's thrown around that can be, confusing. And if you had to boil it down to, here's what I really think that the goal is, how would you describe that? Tom, what are your thoughts with that?
So there are two metrics that I look at primarily. One of them is total UA, which is essentially heat transfer across all of the building envelope pieces. You essentially average out your wall, glass, roof, and floor, and just understand the total thermal performance of the envelope. Then the air tightness is measured with the Army Corps standard in a leakage per square foot of envelope area. And that's basically your CFM reading from your blower door fans divided out over the total surface area of your building facade, including the roof. And those are two really good solid metrics that I think levelize the performance across any building type.
Okay.
I think it's pretty simple. I mean, you take a look at designing a building, and you have to, or you're forced to, bring in the ingredients of a building code, which is changing pretty rapidly. We've got a lot of new energy code adoptions that are very specifically targeting the building envelope. And I think it's pretty simple. A high-performance building is a building that is initially designed to exceed what the code minimums are, or what the code might define as a baseline building. And then, again, through some of these new testing methods that are going to be part of the energy code or associated with LEED, it's going to demonstrate to us whether those buildings are performing as the high performance they were intended to.
Right. Well, so I think you kind of hit a good point there, Bob, with kind of saying, when you boil it down, how do you exceed the minimum requirement? So let's talk about methods. What would be, we've talked about the different RNU values and the different heat transfer. What would be, to you, kind of a boiled down point to how you would reach this, exceeding beyond the minimum requirements?
Well, I think that there's, if you take a look at the energy code, and for me in my professional career, I primarily concentrate on the building envelope or the solid or opaque wall area of that envelope. And with respects to the energy codes or building codes in general and the prescriptive requirements for insulation, for an example, I think that you can design a building to its minimum, or sometimes I even, categorize this as the building code allows me to design and build the worst possible building. So anything I can do that enhances what those minimum requirements are, if I'm speaking specifically to insulation, could be as simple as designing more or additional R value into a wall or a roof assembly, or perhaps looking at other methods of meeting minimum requirements for insulation. For example, in a wall, that could be a combination of cavity insulation and a requirement for exterior continuous insulation in most geographies or climate zones now. I think a higher performance approach would be to look at opportunities to incorporate all of that required R value, say, in the exterior continuous insulation. and remove the cavity. And I think starting to think in those lines of taking what the code minimums are and enhancing them or extending them or bettering them is a good, solid approach.
Right. Blake, what are your thoughts on a strong method to, achieve these high energy efficiencies?
Well, I agree with Bob that we are, and I am pushing our firm, and it's it's a real learning curve here. I'm in North Carolina, and it is a real learning curve here to do continuous insulation and to put it all outboard and into what we call the airspace, into a rain screen. Rain screen is basically the screen right now that everybody is going to, is more high performing, and it works better too, and for a lot of different reasons, but we won't probably be able to have the time. But the continuous insulation creates a lot of problems in construction and things that we haven't normally done. Somehow that window and how it's to be placed in that wall relationship to that insulation, so that not only maintains the thermal continuity of the glazing with the insulation, but we have to use additional angles and so forth to make that happen. And it's kind of a learning curve. We are doing that, and we're putting it all continuous, because bad insulation basically is ineffective and also hides a lot of problems, and also it's better to do it put the insulation in one time than twice. So there's that going on. So right now, continuous insulation and air tightness is getting much more. The press is that, and trying to find more ways to do it with the construction limitations we have, the constructability limitations we have.
Right. Well, so if we're thinking about doing this building envelope, and you're mentioning the rain screen and the continuous insulation, where would you say the installation is where you would begin, or is there another place that you would start with when you're thinking of building from the envelope? What products that come to mind first? Where do you start, Blake?
Well, we always want the continuous insulation, and if we do that, we're going to start with some kind of wall structure, whether it's metal studs, CMU, or whatever. And that's outboard of that to the exterior. We're going to have some kind of air and moisture vapor barrier, and then on the outside of that is put the continuous insulation. The biggest thing too is to try to use clips and so forth. The biggest thing right now with this is getting the cladding on is a challenge, especially learning curve here, and trying to come up with a clip system that works and is consistent and anybody can use, anybody can provide. And we have to provide this stuff cost effective to the client, because after they look at it, and our clients are mostly negotiated jobs, so they're always talking to the client, the contractor. So we have to be very careful and not only influence the contractor what is important so that they buy into it. So we're constantly educating and seeing how we can do this better.
Tom, what are your thoughts on where you think, to begin, which I think he brought up a good point, is that almost you think about the education before you even think about the building, but where do you stand on that?
So if you take a step back and think about, going back to the question of high performance, maybe the answer isn't higher levels of insulation, but the right level of insulation for the building type. You would treat a restaurant differently than you would treat a classroom, than you would treat a lab building. And understanding the impact of internal and external gains and how the envelope either improves them or hinders them. Like with a restaurant, if you add a lot of insulation, you're going to end up having a cooling load penalty. Knowing those things ahead of time lets you optimize where you're going to spend your construction money and your design time, and using the energy model is the key thing for that, and that's where I would start. Great.
Okay, so let's kind of delve further into insulation in this topic. There's a lot of chatter between the typical bat sheet type, the spray foam. We talked about the continuous insulation. I've read articles for both sides. So, Bob, what would you say you think when you compare those? What do you find is most effective in creating this tight building envelope?
Well, I think with respects to those three, we'll say bats, spray foams, or expandable foams, or a continuous rigid insulation, I think any one of those products can be integrated to create a tighter building envelope. And I think more importantly, it is not any one product, but the tightness of a building envelope is going to be related to a number of products and their compatibility and their ability to be properly installed together. It's really, tightness is based on layers and their appropriateness. And a building, its weakest points are at its joints and seams, or areas where it connects roof to wall, etc. And so dealing with that is paramount with respects to proper transition detailing and maintaining the level of air tightness you're targeting. You know, if we talk specifically about the insulation materials, I think that a spray foam has the ability to create the tightest environment. I think a continuous insulation would be second to that, assuming that it's installed in a manner where you're able to treat or address its joints and gaps. And I think perhaps a bat might be the worst of those three with respects to air tightness if we're talking about the material alone. But I think it really is more of a matter of how the insulation component works with the other pieces of the air tightness puzzle.
Right, right. So if we extend beyond even insulation and moving on to other products that are incorporated in this envelope, Tom, where would you say would be other products that you are considered, very crucial in designing this tight envelope?
I think Bob's point about it being a systems approach is a good one.
Right.
It's not just the insulation, or it's not just where you place the caulk. It's how everything works together. But understanding, and Bob also mentioned it, how your materials go together and what happens when a window is put in a wall, or how one wall meets another, is really key in understanding the best ways to address those issues, whether it's caulking or using foams or using some other gasketing material is the most important piece of it.
Right, right. Blake, what are your thoughts about the system approach and kind of, how everything works together?
Well, it's the only way that, I agree with it, both Tom and Bob, that it is a critical issue. It's a difficult one to do. We have some manufacturers that can provide a system, but so often in the bidding process and to get the right price, everybody wants to split this up. So we've had to split our specs up and be more tighter about that in order that we eliminate certain entities from even in the correlation between the specifications to make sure that we don't allow mason to put in the insulation. We don't want them to do the insulation. And so there's some things that we're trying to get the low-tech group separated from this because it's become a very high-performance issues, the air and moisture vapor barrier and the insulation. SPF is probably the only insulation I know that really provides an air tightness, and it has its limitations. It has its strength and its limitation depending on a lot of different things. But there's other products that provide air tightness. Liquid peel and stick sheets, membrane, air barriers, all those have the ability to do it, but they have their limitations too. How do you keep it from peeling off the wall after a period of time? How do you interface it with something else? And so I recently had somebody that combined, a detail came across my desk about somebody tried to mix SPF, spray foam, and also mineral wool. And had a purpose in it. I'm not too sure. And I also used the liquid in there and trying to create a high performance detail for a healthcare facility. I understand the need, and we're probably going to see some more things like this. But it really throws a lot of things in there, how it can be done and still maintain the thermal penetrations and so forth. So anyway.
Right, right. Well, so that kind of parlays to our next. We're sitting here talking about, creating these tight building envelopes. And kind of an interesting, argument that we came across when doing some research over the past year was, is it such a thing as building envelopes becoming too tight and not allowing a building to breathe or toxins, to flow in and out? And if that is true, can you combat that? So, Bob, why don't you lead us off on if you think this is even a valid concern, and if so, how we can combat the issue?
Yeah, I think it's a very valid concern with respects to allowing or doesn't a building breathe. But I think there's a couple of different categories we want to try to put a definition to breathe. I mean, there's one thing for a building to have air infiltration or physically leak air in and out of it. And then there's another element of breathability, or maybe perhaps better said, permeability, with respects to moisture or vapor moving in and out of that wall assembly. Either one of those can lend to a phenomena of condensation in a wall if that wall isn't properly designed with the right materials, somewhat influenced by insulation, but obviously given for its specific climate. So there's two categories there. Certainly, we are making buildings more airtight. The energy codes, the Corps of Engineers standard, which has been referenced, the notion of LEED 4 incorporating building commissioning and testing, that is lending to buildings being tighter. That is going to have to be understood and offset, or balanced is a better word, through the HVAC design. Dealing with a building's permeability for moisture vapor to move in and out of it is critical all the time. And every building design, whether today or tomorrow, really needs to take that into account as well.
Right. Tom, what are your thoughts on buildings being too tight?
You can't make it too tight, but when you do make it too tight, you do have to, as Bob mentioned, deal with your ventilation and understand your vapor permeabilities. And design of the ventilation system is paramount in a tight envelope. It's one of the biggest things we're focusing on now on the residential side here at South Face, and then on the commercial side, doing that with an energy efficient method is a large challenge. So I don't think you can make the envelope too tight. Now you could in a historic structure where the building was essentially designed to get wet and then dry out to the inside and the outside. But with new construction, it's the tighter the better. Right.
My initial reaction to this is a positive no. We shouldn't be concerned about too tight. Number one, all windows leak. Mm-hmm. And if they're new, they leak a certain amount, and the doors and then the building leak a certain amount. There are certain levels of a leak. The best that they're talking about is 0.15 CFMs per 75 pascals is what's net zero is trying to get, or something like that. But there's no way to keep it, and the seals go bad. Uneven doors are the best, so it's always going to leak. The question is whether we make every effort to make it tight and limit it as much as possible. And so my thing is no. But like Bob brought out, climate has a big influence. Where is that? I mean, in some places they don't need as much air tightness. Do they need insulation at all? But we should be building buildings for not one location or one climate or change, and should be prepared for any climate change. And we can do that by controlling the HVAC, the ventilation, and the backups and operable windows that we may put in these buildings.
Well, so if we're trying to work towards this net zero building efficiency, are we kind of jumping the gun and saying that we should start with the envelope first? Is there something that we should even, start with before that? Is there a prerequisite? Is there something that we should consider before even going to that direction? Blake, what do you think?
Well, the building enclosure affects the whole building. It affects the HVAC, doesn't affect lighting or some of the things like that, but if you got any kind of controlled environment, you're going to have to depend on what the building enclosure is. So yes, it's important that it is the first line of defense for the building or for the occupants inside.
Mm-hmm. Bob, what are your thoughts?
Well, hey, let me try to be honest here. Net zero as a target, I think, is pretty far down the road yet. I personally, based on what my professional career has exposed me to and taught me today,
mm-hmm.
that the notions of net zero are just not going to be achieved without some integration of renewable energy. And things like wind or photovoltaics or whatever they might be, those technologies are fairly new. We opened this session talking about trends, and certainly
right.
there are trends towards those new technologies. I don't know that they have found themselves to get where they need to be, or certainly at a cost that can be accommodated by a building's budget. But we have to start somewhere, and we can
right.
start with the building envelope and designing more towards a high-performance building today to reduce our energy consumption by as much or a certain percentage as we can. But net zero, I think, is only really going to eventually be achieved by a more thorough integration of renewable energy sourcing.
That's a good point. That's a very good point.
No,
go ahead.
But Blake, I totally agree with Bob. I mean, it's out there. It's a goal. We want to do it just like AIA wants to their 2030 goal.
Mm-hmm.
I think it's really a good thing that can possibly happen in another 20 years, but we're going to see some significant scientific changes and not only bring it to the market, to the customer, it's something that is cost effective.
Sure. Well, and to achieve that, we need to start thinking that way now, which is, while we're having these type of exchanges, is to kind of breach that subject that, you're right. How do you make it cost effective, but make it a part of the conversation and kind of make that be the trailblazer? So I think that's a very valid point to look from that direction. So if we do, kind of look at it more of a holistic view of the whole building, what would you say is the most significant contributors? If you can kind of pick out the piece parts that are like, this is the number one, this is what's really got to happen in each, of the specifications. So tell me which ones each of you find is most significant. We'll start with Tom.
Well, and this gets back to the last question.
Right.
Your goal is to drive down the loads first, and in most buildings, the loads come from glass, and
mm-hmm.
so figuring out how much glass you need to do the adequate daylighting
mm-hmm.
and get views for everybody, but also not increase gain by having them on the east or west facade, balancing all of those out, and really taking a holistic approach to your glazing ratios, and what they're doing is probably the most significant contributor overall to the performance of the facade.
Okay, sure. Bob?
Yeah, I agree with Tom. And we are seeing, changes in the energy codes that are setting maximum limits or setting maximum ratios for fenestration or vision glass to wall area. And so glass is a major contributor. But also a poorly designed opaque envelope can be a major contributor too. So we've talked about a number of things that can enhance that and move us towards high performance. For me, I think the most significant contributor is improving the R value, making the R value higher, or if you want to look at it from a performance standpoint, getting the U factor lower, and managing mm-hmm. air infiltration are probably two of the most critical contributors.
Sure. Blake, what do you think is the most significant contributor?
Well, I think every component of the facade contributes or affects its performance. We talked about holistic, as Tom brought out, and it's like a body. It's like the human body. We can injure our toe, but we keep moving. But maybe I'm getting a little too into the weeds here about coming up with an example, but basically you hurt that toe, it affects your mobility and distracts you from your thoughts. So to take any one component out and say what is the best, right now we're looking at everything we can put our hands on that is realistic, pragmatic, and how do we apply it to the building. And even pushing beyond that, sometimes it meets all those, but then we have to go against the norm of what is being done out there. So, and we have to appreciate that at the same time moving forward and still educating people and bringing them up to where we should be or could be, and looking for those unique things that's going to make it better. And there are some things that have happened. And I'll talk about that later.
Well, so each of you have kind of touched on education as obviously is going to be a key, and one of the reasons why we're here today to discuss it. So if you are in the shoe of the architect that's having to do the specifications of a building and they're looking at the envelope, what do you think are the biggest challenges they face? Is it lack of education? Is there not certain products available on the market? Is it a cost issue? Where do you think that they have the biggest challenges when they start a project? Bob, why don't you start?
Yeah, thanks. Well, being an architect myself, I think I can say some of these things from past experience. I think some of the biggest challenges that an architect is going to face today and going forward is understanding better how they are going to be able to meet these new energy code requirements or building performance requirements. All right, it's always been one thing to design a building with performance in mind, but it will become an entirely different program or problem to design a building and then test it to determine that it meets those performance criteria. So I think that's a big challenge. And in order for that building envelope to work and function, as we have said here today, it's a holistic approach. It's a group of materials that have to be compatible and work together. I think that there's the need for the architect to begin to take more responsibility in defining what those materials might be specifically. Not necessarily a specification that might be performance-based or list 3 or 4 different materials or manufacturers. I think that we're going to have to begin to look at those detailing conditions more specifically and know in advance of bidding or in advance of construction that the materials that will end up in that location are compatible and will accomplish the overall goal. I think those are the real challenges in the very near future.
Sure. Blake, what do you think are the biggest challenges?
Well, since he's picking on architects, I guess I'm going to speak up. No offense there, Tom. But anyway, the biggest thing, and it's true, the code is a big issue for us, and the biggest one right now is the NFPA 285 that's been drawn out here the last couple of years, especially the last year, which has to be approved with wall assembly requirements. That is really finding products that we can put together. All of a sudden now we got to have assemblies. We can't have products. With this particular one, we can't even improve the building enclosure because now somebody's got to pay $25,000 to get something tested, and so that's quite frankly limited us in what some of the products we've been using is for high performance. Constructability, we're still struggling, yes, with challenges with this architect. We can spec it, we can do it, and then all of a sudden we get out there and somebody isn't doing what they're doing. And I'll talk about from each standpoint of what I think needs to be improved later on with our discussion. but we're detailing. We got shorter schedules, shorter budgets, and we're trying to get the detailing out there. But sometimes we get it out there, and then somebody starts changing it, and we try to get through the submittal process through this and everything. But it's hard sometimes to keep the communication going. Us, as though, is a big education of the construction industry. It's one reason I'm a member of the Building Enclosure Council and started one in our area, because we're trying to educate the people in the construction and even the architects of what building science is and how to do it better for the last 3 years. So anyway, those are some of the pet things I see that basically, though, it's down to educating. People don't know, and educating it all the way down to the bottom people. To the bottom worker that's actually putting it on the wall.
Well, that kind of is also kind of goes into my next question: is if you are, these building product manufacturers, how do they address these challenges? I mean, we're talking about, if the architect specs one of their products, but it doesn't get installed correctly, what can they do what are some ways they can work through these challenges to ensure that the products are being installed correctly, or they're even being spec'd for the right reason? Tom, what do you think is a good way to go about that?
It's quality control is one of the things we deal with here at Southface a lot, and it's the real challenge is that the skill set of trade contractors varies greatly, and the skills needed to install some products is fairly low, but others, it requires a lot of attention to detail. So we talked about training, and we talked about being able to understand the detailing and stuff in the last question, and that's really the key thing is the product manufacturers have to understand how to communicate the best way to install their product, and in some ways validate that it's being done properly, and that gets very expensive for the product manufacturer to go out and inspect every job, but in some way that has to be done.
Right. Bob, what do you think?
Let me add in. I really agree with Tom's line of thinking here. But what I would like to suggest, in that I represent a product manufacturer today, is that again, if I manufacture one product, and in this specific detail condition, there could be 3, 4, 5, or 6 different products. There could be 2, 3, 4 different subcontractor trades. And then you do the math. I don't know how to do that equation, but somebody can do that equation as to how many possible scenarios, right? So it really boils down to a matter of coordination. And Tom's point about skill set is critical to understand. That any one person in that equation does not understand perhaps how all the other materials work, or what is the proper steps of this scenario and sequencing. And so what we, my company, as an exterior insulated cladding manufacturer, what we try to get engaged into the building envelope is a consultant, a forensics or a building envelope consultant that does have these experiences and can take control of the situation and guide the trades and help the general contractor with those coordination responsibilities. I think that that's really a critical step. It may develop, and let me just add, that may be a small added cost to the overall construction budget, but the end result of that building and its ability to hit these performance criteria, which it's going to have to do in the long run for that building's life, are going to deliver substantial returns on that small initial investment.
Yeah, and being able to quantify that return, I think, is a key thing that's missing in the way we go about designing and constructing buildings now. It's difficult to quantify airtightness.
Yeah, I think that's why it's ambiguous to a degree.
Well, Blake, I'd like to put my 2 cents in here.
Yeah, please do.
I'm strong. I feel strongly about this area. It's true. We need to make it easier to construct and interface with other components. And the manufacturers sometimes don't help us. We get shop drawings that are not coordinated with other materials. We ask for in our specs, we check it, and what we get is something that totally ignores everything around. It's like they didn't even try to talk together and work it out, or even ask questions before they did. We have pre-installation meetings. We also have pre-construction meetings. We have all these meetings and everything, and yet we still don't seem to get this from the manufacturing side. I'm not trying to lump that, just like you guys you don't lump architects all together. I don't lump manufacturers together. But at the same time, it's a big problem that we have, and it doesn't take one to not do it well. So we need architects, we need help from the manufacturers to educate contractors, subs, and their workers, especially when it comes to their product.
Right.
They need to come out. We want manufacturers that have somebody within an hour or 2 hours of the job site that can come out there and say, hey, and watch it get started to make sure they're moving and doing what they should, that they were showing on the mock-up. But normally we get mock-ups, we go to all this money and effort, and yet we don't have the guy, Joe or Jose, out there that's looking at these knows how it went in. So we are even trying to do better mock-ups now that shows the increment, the element of implementation, the sequence of implementation. There used to be a mock-up was for aesthetics. No more. It is basically to show how the building comes together so it can also be tested. And somebody can see it and know this is what you're supposed to be doing. And a lot of it's visibility, visual, for these guys out there doing. They can do it, but sometimes you got to make sure they're educated and they understand it. So I think everybody has a responsibility, from the general contractor. You can keep putting this off to somebody else, but it just kind of gives more. Instead of, architects need to do it, contractors, manufacturers, all of us need to do a better part of this.
Right, I think that's a very good point, and I'll throw it back to Bob on this. With you representing a manufacturer, how do you feel like you could take what Blake is saying and contribute to how you can ensure that these architects and these contractors are really installing and knowing how to use your product? Is there something that you think y'all do really well, or some ideas that you think that could be successful in teaching how to use these products?
Yeah, no, absolutely. Blake's point is very valid, and it goes again to the overall conversation of we've got a lot of parties involved in a process, and how can we bring those parties together so that we can have a more comprehensive understanding that can lend to better installations and sequencing and coordination. Now, I think that manufacturers are very willing and able to participate on projects or through pre-installation meetings. That really is just a matter of coordination to take place. I think that manufacturers are doing the best they can to create training sessions, whether they're for designers or installers or other related parties, general contractors, etc., through continuing education sessions. Regretfully, we all can't spend 8 hours a day on the computer watching a lot of webinars. We've got to get some work done at some point.
Right.
And so there's a line there where you can bring that in. We'd love to do nothing more than be able to be in a position to educate. But I think those things are out there. They just have to be recognized and taken advantage of, because they are there for the offering. Here's one.
Sure.
Part of the challenge, or I'll even say problem, is a design bid build process. Okay. Now there are other processes that could be integrated, whether they're through paths of IPD or whether they're through paths of design build. But when we design the building and then we bid the building and then we go to build the building, sometimes there's disconnects there, because in a lot of cases or projects that we experience, architects, the original architect, does not have construction administration responsibilities. He may not even be involved in the project at a construction point. So there are delivery methods that I think can further enhance that. But those are some of the things that I encounter. But I'll
Sure.
speak for the manufacturers in saying they're very willing to try to play a more important role in that process.
Mm-hmm.
Bob, I don't know. The architect has got insurance. Well, he wouldn't have insurance if he didn't do CA. I mean, basically that goes against any kind of insurance, so I'm not sure it's another issue. But the biggest thing is me with the manufacturer. I need you out there when it starts up. That rep needs to, are they really going, are they putting it up right? So, and those guys are not the guys. And a lot of times we've got one supervisor they've got that saw a training exercise on a product, and yet he's got 5 jobs. And so he's trying to make all 5 of those jobs and make sure they start correctly, and they're all running on the same day. And so his way to make sure to get that start, but if we can start, usually any worker with the right understanding from the beginning, they usually can follow through with that.
I agree wholeheartedly. I think pre-installation conferencing is paramount to getting the project started in the right direction. No question about it.
Tom,
well,
what are your?
Or
go ahead.
Well, the only thing I would say again, though, Bob, what I'm trying to say, there's a difference between pre-installation and startup, and I've had to distinguish those because everybody. Well, we had the pre-installation, but I need you out here starting the guy. We already did that talking about it, but now we need the guy that's going to actually do the work, because all the supervisors are in the pre-installation, and then I got Joe or Jose out here struggling to get started, and usually they don't unless we got somebody out there in the and superintendent. Sometimes it usually has somebody, but we're seeing architects actually hired by contractors to make sure that everything is kind of working together. It's kind of interesting concept that's happening on the West Coast and has been for the last 2 or 3 years. They're actually hiring architects to make sure that it's coordinated and work with them out there and kind of understands all that and the design itself.
Well, that goes to my comment earlier about having a third-party consultant engaged on the project. Even if we have 5 manufacturers' reps standing around a window installation, those 5 reps still don't know a lot about the other person's business or materials or functions. But somebody in a consulting capacity, and our conversation is about building envelopes, so let's leave it with that, a building envelope specialist that does have an understanding of those 5 people and what their roles are, I think is really what projects need.
Well, I think you've seen a lot of... I want
to give Tom a chance to speak up.
Go ahead. Yes, I'm sorry.
I'm actually
Tom,
enjoying this conversation. So
yeah, I was going to say, Tom, do you want to have something you're thinking of at the same time?
No, I think Bob's point about the consultant is critical. And if it's not the architect functioning in that role, then somebody has to do it, because someone has to understand how everything goes together. It can't just rely on product manufacturer X saying, oh yeah, he put my stuff in correctly, without any regard to how it interfaces with product Y. And that whole systems approach, again, that we keep going back to is really the big thing. And for product manufacturers to ensure that, I mean, that's no one likes to insure anything, so
right, especially a product that's not theirs.
Yeah, it's so somebody eventually gets put on the hook, and that person needs to have a really an understanding of how everything works together.
Sure. Well, it sounds like there's a lot to even further discuss this, this topic. It's very, and this really is kind of the meat of our conversation here is, how can the product manufacturers help the architects and contractors, and vice versa? How can we come together and help each other in the best way? So there's definitely opportunity out there, I think. So I'm glad we got to kind of breach that. I want to give everybody one last chance to kind of, bring up any information or topics you felt like you wanted to discuss or kind of close out with before we end today. So Bob, I'll start with you. If you have anything you want to kind of end on or didn't get brought up that you feel like needs to be said, now's your chance.
Yeah, well, thanks a lot. And thanks to the other gentlemen on the call today. I appreciate your input and dialogue. And And every opportunity for education is critical, and developing this webinar is another means of education, and so that's very, very important. We talked about a lot of things. I'll summarize some of the more valuable points that I found in the conversation. I really do think that there's a lot of things changing on us very rapidly, whether they're energy code related, whether they are building performance testing related, whether it's NFPA 285 fire test, which has been in the code since the year 2000. These things are coming to the forefront of design and construction. Manufacturers are catching up to these requirements. Folks are developing solutions, but it really is today going to take more of a holistic approach, which we've said, because every detail or every joint or gap or seam in a building envelope involves more than one material and more than one player. And so coordination of that is going to be critical. With respects to building envelope, I think that the best way to achieve or easily, cost-effectively achieve a high-performance building is by increasing the amount of insulation utilized in that envelope. And so I'm going to leave it at that and say thank you very much for the opportunity to be with you today.
Thanks so much, Bob. Blake, I'll give it to you for what your final thoughts are.
Well, I think I appreciate where everybody's coming, and I appreciate the construction industry. I think everybody is struggling to make things work and to make better buildings. I think that we've been trying to resolve these issues, and I think it's the whole design and building industry. I think that some, and as far as I'll be pointed about, some of the architects have actually delegated and don't want it. They just want to do the pretty stuff, and they want to turn it over to somebody else to do the building enclosure or the details of what that should be. And that is becoming a trend for some, or a lot of firms. And a lot of firms have just got rid of all their technical people and all the people who had knowledge in their firms. And we've hired several of them in our area, from our state. But at the same time, those same ones are becoming building enclosure consultants, and they're going out now, and now they can get paid on the other side and do what the architect does. In all fairness, the architect, it's shorter schedules and less dollars, and trying to do it faster, quicker, and everything. And what happens is the details are missing, and that's basically the details is basically what is the crux of the building enclosure consulting side. It's just looking for those details and how to make those things work for architect the other time. And details is like anything. It's the last thing that is done on a set of documents. And it's one that nobody understands until they start building.
Right. Well, thanks. And Tom, I'll have you finish up with your final thoughts.
Great, thank you. I think just stepping back to my point about finding what's appropriate for whatever building you're designing and doing that through analysis is the one key thing. But also understanding that the envelope is one of the components of the building that typically will not get changed out during the life of the building. We'll put new mechanical systems in, and we'll change interior finishes repeatedly over the life of a building, but the envelope usually never gets touched. So you have to give it that import when you're designing it, that it's the life of the structure that really depends on the facade being the big piece of it. Of its existence.
Right. Well, thanks, guys. I really appreciate you each have a very unique perspective, and I think it's good to hear from the architect side as well as, from the manufacturer and the consultant. So thanks again for taking your time today to share with us your thoughts, and I look forward to working with you all again. I will definitely, this recording will be posted on our website shortly, so hopefully we will have some good feedback. We may even have some additional questions from people, so be on the lookout. You might get an email from me asking for some more insight. But thanks so much for joining me today.
Great. Well, thanks for having us.
It's a pleasure.
Enjoyed it, guys.
Thank you.
Thanks.
I did.
Thank you very much, everybody.
All right.